This is Visions Under Construction, a chance for our guests to share their visions and tell us what they're working on. For their continued support, we'd like to thank Simwood.com, who can turn you as a developer into a telco. Why not make Cloudonics your communication partner? Go to cloudonics.io. You can find everything about the VUC at vuc.me, thanks to Bluehost, and thanks also to zipdx.com, the conference bridge, and to voxphone.com for local rate dial-ins. Before we, oops, mixer, oh, dirty pot. And when I say dirty pot, I'm talking about a potentiometer, ladies and gentlemen, with all these ham radio guys. Come out of your world. Chris, are you coming? Not this year, I think, huh?
No, not this year, unfortunately.
I love talking to the guest when I haven't introduced him, but that's okay. He doesn't need an introduction. Come to Berlin if you can. Check Berlin out May 14th to 16th. Many of us here will be there. Actually, not that many, but some of us will be there. I don't know what we have to do to get Corrado there, but we'll work that out. And it's a great show, and I just want to mention that because Daniel has just improved year after year. He and his wife do a fantastic thing, and the social aspect of it is totally unpretentious and all of that. It's just people having a good time. We got Fred's going to be there with his wife. And
I'm going to be there with my wife and my mother-in-law.
Seriously?
Yeah, hot date for
Fabulous.
you.
I can't wait to meet her. All right. Anyway, let's try to get the camera happening over here. And how quickly can I do that? There we go. Hey, there it is. So as I said, Chris Matthieu's here. And before I actually get into any deep discussion with him, I just have one question for you, Chris, besides welcoming you, which is, you know, I don't understand why you just sit at home and do nothing. You have so much potential. Why don't you get out there and create a company, for God's sake?
The next company, the next big thing.
Right.
I'm always in quest for the next big thing.
You are not the next big thing. You are the current big thing, always, which is commendable.
Oh, y'all are too kind.
Anyway, Chris, what is this? You're from Phoenix, aren't you?
Original Louisiana, so there's a bit of a southern in there. But yeah, I've been in Phoenix for probably 30 years. So you think it'd be beaten out of me by now?
No, it's folksy and it's great. Chris, I want to ask you, we've been through your, I mean, people can go look at your LinkedIn and there's a long list of companies and things accomplishments and so on. And we've talked, I'm sure we asked you already how you got into technology. You know, you've been on a number of times. So I have a question that relates to what we're trying to do this year with VUC, which is to say, what is it that gets you out of bed in the morning? Not a person, not family, not you know, that the official public side of your life. Why would you keep going with all this stuff? What is this challenge that you face day after day? And tell us a little about it, not just answer the question.
Well, you know, that's a fantastic, thought-provoking question. I think in my earlier career, and you guys can probably all relate to this, and still somewhat today, is that technology in general is interesting, right? You find something new and innovative, and it's not a job. It's like you want to play with this stuff. You want to experiment with it. But I think the older I get, the more I actually want to leave a legacy behind, you know? So you start combining the two where maybe this new emerging technology could result in a legacy. I think there's not enough time in the day to accomplish this, you know, this goal.
Who shares that? I will immediately say that I do, not that I've done what things that Chris has done, but just in general, the challenges that I've faced running a company for over 20 years is one of them. And Corrado, you will have your own.
Absolutely.
Company. How do you feel in the morning? Same thing, right? We all feel that.
Yeah. Especially that when you create something is something that as men don't kind of experience, is like giving birth to something. It's creating something that lasts after us. So
it's more like second-class experience of birth, right?
Yeah,
without all the
less painful.
They
I
are
don't know,
pain.
probably.
Well, it could be pain actually,
Yeah.
but in fact, has there been pain, Chris? Because you're a big success story. Are there some
Well,
horrible failures you want to forget?
oh, I mean, you guys, I mean, it's easy to see the successes, but yeah, it's not so easy to see all the 24-hour shifts, you know, working around the clock, the frustration of trying to bend this technology to make it do what you want, and the tears of the agony of defeat. You know, I mean, that's not so public usually, but there's usually more exhausting experiences and successful experiences in my book. And to Carano's point, you know, I think it's one thing to create the technology, and Randy, hats off to you, because I think it's even more difficult sometimes to create a business around the technology that you think is so fascinating. And I think if you can do both, you know, that's a magical experience.
You know, it'd be great, Chris, is if you could, I don't know if this is possible. I'm just going to spit it out. If you could take us through this fictitious scenario, you wake up. So you woke up in the morning. And by the way, you probably wake up at 3 o'clock in the morning. I have, and go, oh, yes, of course. So you've got this either innovative or disruptive technology idea. So you probably, this is a guess, you correct all this, right? So you probably start screwing around at home with it, maybe try to do a prototype or just test some kind of a proof of concept. What are the next steps? First of all, do you do that? And second of all, what are the next steps? You start to recruit a team. How does that all work? I'd be very interested in that.
Yeah, so it's usually a crazy idea that you might get on a Friday, you know, and you're going into the weekend thinking you're going to enjoy the weekend, right? You get this crazy idea, and all you can think about is this possible? Is this crazy idea even possible? So you start tinkering, right? And you maybe make some progresses, and the next thing you know, work rolls back around on Monday. You've got no rest. And you can't even focus on your job anymore, because all you've got is this idea that's haunting you day and night until you make some progress. I've been fortunate enough to have a lot of technology friends like yourselves in my life. You know, my whole life, that you can bounce to any one of you guys or any other friends that you have and say, am I crazy? Like, does this make any sense at all, just for validation? And you know, 9 times out of 10, if you get the you're crazy, that's even better. That's even more of a reason why you should do it. So I think surround yourself by bright, intelligent, creative people, you know, like this community. And if they don't say you're crazy or don't run you off, they might actually want to help you.
So what are the first steps?
Sorry.
No, go ahead, Carano.
No, usually when someone says to me, you're crazy or that cannot be done, my answer is challenge accepted.
Yep.
Yeah, that's a good point. And I think that somebody like Elon Musk, I'm sure, has been heard he's crazy a million times, or other people of that ilk, maybe even Chris, I don't know. How specifically, though, all right, now you know that you can't do it alone. What are your techniques for finding people? Do you just tell people, because you know a lot of people, like some of us here. So do you just put the word out? Yeah, I need somebody who's good at Python, or how does that even start?
So what I started doing probably 10 years ago, I started building meetups in Phoenix, Arizona. So I built the Node.js meetup way back when we were starting to play with this idea of creating Nodester. It was the Node.js platform as a service platform I built when I was at Tropo with Jason Gecki and Diggs and all those guys. So I created a meetup to really talk about Node.js and get the like minds together. And that meetup is still going on today. And then when I started getting into IoT with Octoblue, well, guess what? I created an Internet of Things meetup in Phoenix as well. And that thing's grown to over 1,000 people. It's still happening every month as well. And I think those vehicles bring you a lot of talent. You know, they bring like-minded people into a recurring meeting where you can either start socializing your own ideas or listen to other people's ideas. And people technologists especially feed on each other. You know, someone says, hey, check out this cool thing I did with an Arduino. Well, the next 3 meetups are about other crazy Arduino related ideas, right? So I think that's a good vehicle, and you'll find that like-minded people or like-minded ideas organically come together through just conversations like that.
Excellent point. And also, of course, conferences like Communio, for example, in Berlin, May 8th. No. Any of these things. I mean, you and I met in Phoenix because you lived there at the time and still do, I guess.
Yep.
At an Astricon, I think that was the first time I met you, maybe even the only. And I have a very strong memory of that. And I want to say in parentheses, by the way, and this is not to shine your shoes, Chris, but the thing about Chris is he's not just another person with ideas. He's memorable. And it's not the mustache, although that helps. But Chris, you're a very personable person, and you're super positive. And James, Andy, have you met Chris? I think you have, probably. No?
Yeah, I was there
James,
in Phoenix when
right.
we all met, and of course,
and you've met several times, right?
Yeah, and the moustache wasn't there when we met. It's evolved.
Yeah, so that wasn't the main thing. But isn't it true that he's got somebody UPS? UPS is at the door, so we can talk about him now. Oh, here he's going to show his badge.
I had to get my True Phone award.
This demo trophy.
Yeah, that was quite the experience at the Astricon. We won the dangerous demo. Yeah.
It was very much deserved.
You know, I'd actually forgotten that. I was about to say that I don't think we have met, but we must have done.
I'm sure we have.
Yeah, 'cause I've been at all the Astricons where those were given out, apart from last year's.
This was 2016, it says.
That's last year's, so I don't think we have.
It's 2018 now.
Yes, I'm living in the past, don't worry.
Yeah.
Still signing your checks with the 19 something, right?
Checks? What are they?
Yeah, I realize. I haven't touched.
I remember the T-shirt cannon, which is an integral part of your demo.
Yep.
Dangerous.
Right.
Anyway.
Well, my point was, James, and that's why I pinged you and Andy, is that these things, technology is something, we all meet online all the time, and that's great. And what Chris was talking about, the live thing is huge, and people are not always they don't always realize how important that is. And so I just wanted to underline the fact that, first of all, you need to go to these things, and second of all, you need to be somebody like Chris. I don't want to embarrass him, but somebody who's positive, and when you're hanging out, it's like, yeah, that's great, and because you meet all kinds of people and you never know who's there, right? And that's
absolutely right. And it's at these meetups that these ideas are born. They're these delicate, fragile little things, and all you need is a little bit of reinforcement and support from your peers, and these little wimpy things become real.
Exactly. All right, let's see. We still have a few minutes.
Well, I hope so. I haven't heard about the new startup yet, and I'm trying to find out which is
that was the segue, James. So Chris and I were riffing on the idea of mesh, and I asked James about it. We talked about it. The question is it better to discuss what mesh actually is, or to just get right into Computes.io? What would you rather do? Because people, I think, don't know necessarily what the concept is.
I could tell a little story, kind of kind of the inception, if you will, like James had kind of mentioned, when these little ideas are born. So coming off the coattails of Octoblue, that was my last startup. It was an Internet of Things mesh networking platform acquired by Citrix. We did that for about 3 years, but every time I would give a talk about IoT, I would always point out this Gartner or Forrester prediction graph that said 50 billion connected devices coming like 2020. And it kind of got me thinking, like, I'm a programmer, so I'm sitting in front of my laptop all day long hacking or building stuff. And I look at my CPU utilization, and it's like 80 or 90% idle, even with me working on it, surfing the web, checking email, what have you. And then at the same time, you see those Gartner numbers of like, 50 billion connected devices coming to the market. And I'm thinking to myself, these devices are like Raspberry Pis. They're maybe chirping temperature sensor data like every 15 minutes. They're idle too. They're mostly idle too. So then I started thinking, what if you could somehow harness all of this idle compute on IoT devices, workstations, server VMs, etc., tie them all together to make them act like a single computer, almost like a software-defined supercomputer, if you will. What could you do with that? Well, first of all, to our conversation earlier, is that even possible? Like, could you even like connect all of these in an easy fashion, or allow them to organically kind of mesh, communicate, and compute together? Is that even possible? So those were some of the Friday or 3 a.m. ahas that ended up being moonlighting opportunities for like the next couple of years until I have a full time to focus on this exclusively. And luckily, Citrix had decided to open source the Octoblue platform and kind of wind down the operation. So, Randy, to your point a minute ago, I had my whole Octoblue engineering team at my disposal, who we had worked together for probably 4 years together. And I said, hey, I've got another crazy idea. Rather than building a mesh network of IoT devices, maybe we could build a mesh computer of disparate CPU and GPU resources. So they took the challenge, and in great tradition, they rewrote all of my technology, which all of my proof of concepts I'd written to date. They follow behind and rewrite it all, and it runs better, it scales better, it's faster. So God love them. And we really have a working demo, an alpha of this that can run on any operating system, Windows, Mac, Linux, soon, hopefully, iOS and Android, where all of these disparate CPUs and GPUs mesh together. They connect, they discover each other automatically. They can create a private mesh network, communicate peer-to-peer, and either request computational work or perform computations as if they're a single computer. And it's kind of fascinating. There's a bunch of use cases, a bunch of companies we're talking to about what this can solve. But I mean, in my mind, we were talking about leaving a mark on the world. We're doing Parkinson's research. University of Wisconsin's doing some Parkinson's research with computes today. I can't help but think like cancer research is around the corner, genetics, genomics. I can't help but also think counter cyber terrorism or whatever world opportunities to make this world a better, safer place are all on the horizon. And the best part about all of this tech is that it's decentralized and distributed. So kind of like this whole blockchain movement, except we don't use blockchain. It's decentralized, meaning that there's no additional infrastructure required to basically activate this new supercomputer capability within large organizations. So I think that's the most fascinating part, is that with computes, everything just computes. Everything just interconnects and computes. And I think that's creating a bunch of interesting use cases. So I'm going to pause. I've fire hosed you guys. I'm going to pause for a second.
No, I have some questions.
That's excellent. Well, wait a second, Andy. I wanted to just ask a question that just popped up before it disappears. And it's a short answer. Who asks, will it on IRC? Will it run on Linux? Will it run on Linux on IBM Power processors?
So we do. So it's written in Go. So we decided to write. We normally are Node.js developers, and everything we write is pretty much JavaScript. But we decided to write it in Go because Golang from Google, it can compile to any of those three languages or operating systems: Linux, Mac, and Windows. I don't know if it supports Power PC at all, like RISC processors. That's maybe a Golang question. But the other cool thing about Go is it's highly optimized, it's highly efficient, and it compiles to a very small binary. So the idea is to get this little computes nanocore, we call it, everywhere, and then all of these machines, kind of like Skynet, just start automatically interconnecting, intercommunicating, and computing with each other very efficiently.
Okay, Andy, you had a question or a comment?
Yeah, I like the idea, but at the same time, as somebody who's had a few servers hacked and found them mining Bitcoin recently, it smacks me to me immediately that this is a huge botnet network, malware botnet network that you have control of.
No, I think in the wrong hands, it could be probably the best botnet in the world in the wrong hands. I completely agree with you. What we're focusing on today is private organizations private B2B organizations that feel that they can't get enough compute to do what they need to do: machine learning, AI, deep learning, data analytics of IoT devices, running behind their own firewalls, their own secured machines. We are introducing Docker containers so that there's still some security mechanisms inside of their private mesh computer. But yeah, so we Andy, that has crossed my mind many times. That in the wrong hands, it could be the best evil, malicious machine, as well as the best good intentioned cancer curing machine as well.
Yeah, I can see both sides of that. And there's another aspect as well, which is, as we all know, when you're using idle computing power, if you're continuing to do other things at the same time, you don't really want your processors cores to hit 100%. You want to leave some space. So is there control for such things in here?
Yeah, so not yet. We're still very early. We've been only focused 3 months full time on the tech. We have an alpha that works. We're doing genetics, machine learning computations on top of it that I'll talk about. But the idea is, to your point, we're going to add levers in there so companies can say, never let it run, past 70%, capacity, or always give the user preferred, priority instead of the computes, or, it's designed to run always in the background while you're working. However, kind of like the SETI project and those things from yesteryear, they could just pop up as screensavers too when you step away, which, as a company would determine how to best use this compute. They would be realizing more electricity spend, right? Like if they're using it when the user steps away. But then again, if you do the computations of maybe using their own infrastructure versus using AWS, I did some calculations like 10,000. So companies, a lot of companies have 20, 30, 40,000 workstations. I did this 10,000 workstation computation for what it would cost to run. Like you'd run computes maybe on 10,000 workstations in your company, what it would cost to run that in AWS. And it came out to like almost $9 million a year to run 10,000 active. Actually, I did 11,000 instances in Amazon to compensate that 90% idle ratio. But companies. So here's an interesting thing. So when AWS was started, the original idea behind starting AWS was someone in Amazon.com said, wow, we have a lot of infrastructure here. We're planning for Black Friday and all of the excess, capacity. Someone said, hey, let's just carve out all of our excess capacity and create this cloud idea that we can rent or sell computing to other companies willing to pay. But in an organization, if they could do the same thing that Amazon did with AWS, but leverage their own computes for their own needs, for their own machine learning, AI, data analytics, processing, whatever, that's a very interesting use case. They might not need to spend that $9 million a year in AWS anymore. They might be able to pull that compute back on premise, or better yet, edge computing, mobile networks, IoT edge networks, self-driving car mesh networks. I mean, kind of think of the potential of where else you could apply this newfound compute.
Yeah. You know what, Chris? I think the challenge is not so much making the tech work, because I know that you can do that. The challenge is going to be convincing individuals or incentivizing individuals to allow somebody to use their system. And
you're spot on. You're spot on, James. I think and our original approach was just purely B2B. We tell the true phones of the world, you have all of this excess capacity. What could you do with your own machines if you could reclaim all that resources? I think the longer tail of this is, maybe you could rent your own CPU out to other companies that want to use it as well. And that's where I think, start getting into a lot of, maybe I don't want Russian bots running on my corporate network, so to speak. But right now, we're trying to make a private mesh computer for every company, where you can gain the power of reclaim the power of your own resources.
Yeah. And on the subject of power, clearly, computers do consume more power when they're heavily loaded. And so there is a finite cost there. And I'm just thinking, I mean, worst case, you could actually have the whole thing take down the US national grid by suddenly hitting all of the US with this incredibly massive load, and power spikes suddenly.
Well, look, that's a good point too. Look at what blockchain's doing. Like, all the power required to mine, the blockchain. I can't remember some of the numbers, where they were like the power of an entire country, is going to mining the blockchain, right? And when we set out to build computes, we were trying to build a decentralized distributed computer, which sounds a lot like a blockchain computer, but we didn't want wasted compute for mining. We wanted every bit of compute to go to something useful. So we said blockchain's not the right way to do this. We ended up building our own distributed ledger technology that's not based on blockchain, where all of the compute is useful rather than going to wasted. And I love that no blockchain sign. The other point was, with the blockchain technologies today, their throughput is really slow. Like, I think Bitcoin is like 3 to 6 transactions per second velocity on their blockchain platform. Ethereum is something around maybe 12 to 12.5 transactions per second. We're trying to get to thousands or millions of transactions per second on computes with no wasted proof of work. So rather than mining and destroying the power on proof of work, let's try to use those cycles for curing cancer or Parkinson's, or finding the next world's largest prime number, maybe.
Really useful. So just going back to that incentivization bit, that's what really interests me. What will you give me to open up my computing capability?
So you're getting ahead of me. So the way we're doing it today, focusing on B2B, is that we're telling companies, rather than you spending $9 million on AWS, why don't you reclaim your own CPUs and GPUs to do your own cloud processing? So move your compute from cloud back to on-prem. So they're getting tons of savings out of that. I think in the future, to your point, James, I think in the future, it would be interesting to say, hey, world, let's create a machine economy where anyone with a Raspberry Pi or a Mac or a gaming machine or Windows machine could basically earn maybe a coin type of a token type of a value based on your computes per second, kind of like a MIPS type calculation or something that's fair for everybody, where like, I guess, Airbnb for computers, right? That's kind of where you were going with that.
Well, one way of doing it actually would be to offer the way that you get to participate in the scheme is that you have to put computing power into the cloud in order to use it. And the great thing about that is it's just like a hydroelectric scheme where you save up power, or battery. So when you're lightly loaded, you can allow people in and you build up compute creds. And then when you have this massive spike and you need to do things really quickly, then you let it all go. So that could work, couldn't it? Because
I think it could.
Yeah, that's finite.
That brings us to business model, though, James, because then there would have to be some kind of commission like trading and so on. So I don't know if you've gotten that far, by the way. What is the model? I mean, so if somebody goes and signs up, somebody being a business, obviously, what stage are you in? It's alpha, beta, or operational?
We're very alpha at the moment. Although, like I mentioned earlier, we do have the University of Wisconsin that's using Computes Live to do Parkinson's research today. So we know we're beyond the stage where we didn't know if this could work. It works. We're still tuning it and adding more capabilities to it. We are planning a beta release at the end of March. So like the last day of March, we'll get a beta. And there's over 400 developers in queue on the waiting list, if you sign up on computes.com. So there's a serious interest in the platform. There's really three business models, or really two business models, but there's an interim step. So right now, we don't really have the utility metrics in place. It's so early. So companies that want to get in early, that realize that they can save millions of dollars by moving cloud compute to on-premise, we're looking at licensing fees, like site licensing fees, because that's simple at the moment. What we would like to do in the second quarter of this year is add utility monitoring capabilities. So you could get to the point where it's pay-as-you-go utility pricing, kind of like to James's hydro grid suggestion. You almost treat it like an electricity type grid, and you'd be incentivized to install the Computes Nano Core everywhere in your infrastructure, your servers, your workstations, maybe your mobile devices, maybe your IoT devices, and then you would only use what you pay for, what you use, as kind of like an electric utility.
Yeah,
that's
I think the electricity analogy is really quite a good one, so that you kind of build up credits when
Can I just put my refrigerator on it, or
if you got like a Raspberry Pi or something in there,
there's a question which is actually a good question, and hopefully it's understandable, which is how is it married to storage and network? And I think that wants to get into a little bit about the structure, so we can get into
so there's a lot of interesting tech that Computes is built on top of, which tie into that answer. I don't know if you guys have heard of IPFS. It's the Interplanetary File System.
David, the guy behind IPFS, was at TAD Summit last year.
Oh,
you
Juan?
should have been there, Chris.
I know. I've met Juan once, and I talked to him a bunch of times. Protocol Labs has open sourced this IPFS project, and on the surface, it sounds like it's just a peer-to-peer file system, which is also really cool. Oh, it's not. Underneath, once you start digging into this, it has all of the networking capabilities that perform the mesh capabilities that Computes uses. So by default, it's a big public mesh network. It's kind of like Git meets BitTorrent, like all stuffed together, where you've got versioning of each file or hashes, and then you have the BitTorrent like discovery mesh networking capabilities. But you can create private mesh networks of IPFS as well by just adding a shared key that every node in your network uses, and then it only allows like IPFS networks to swarm, or nodes to swarm together and interconnect. There's two or three other really important parts of IPFS. One is they have a pub sub capability. So like all the IoT world with MQTT and messaging, where you can subscribe to channels or topics and publish messages, IPFS has pub sub built in, again, with no infrastructure required. You kind of get this peer-to-peer messaging platform built into IPFS that many people don't know about. And then probably the most important thing, in addition to that we use it for, is, like I mentioned, how it's Git and BitTorrent kind of like combined. they have this DAG, a Merkle tree type part of their platform where you can track the versions of documents by hashes. And then what we do is we basically treat that Merkle DAG, a directed acyclic graph, as our ledger. So basically, we're able to tie like child transactions to parent transactions to grandparent transactions and create basically a very, very fast distributed ledger off of the IPFS DAG. So the DAG, the messaging, the peer-to-peer file system, and the mesh networking you get out of the box with IPFS was kind of what the aha moment that we said, wow, this is possible not only to do today what we wanted to do, but also to do it without blockchain technology. That was the aha. It was the discovery of the.
Well, yeah, I just had an aha, and that is I'm going to get you and David Diaz from IPFS together for a dinner somewhere.
Oh, I know. I met David Diaz at Stanford last month for the first time in person. He's brilliant.
In fact, I know exactly where we can do that. I'm hatching a plan, but I'll share that later.
Yeah, and oh man, can you imagine getting the three of us together? Oh Lord.
Oh, we could be dangerous, couldn't we?
So why was, and I actually created that not blockchain graphic earlier this week, specifically because I saw that on your website. Why avoid that other than the obvious, which is it's the flavor of the month and everybody's, I did an intro a few weeks ago, now with, VUC, now with blockchain. No, not really. So yeah, it's turned into a thing way too much. But besides that, why not?
Well, I think there's a pro and a con. The pro speaks to the performance gains that we can do without the blockchain. So rather than a dozen transactions per second, which you can't build a supercomputer on a dozen transactions a second, right? Yeah. We're trying to get to millions of transactions per second, and we think we can do that with the DAG approach. Second, you don't have the proof of work mining that are the wasted computations that the blockchain requires. But that's the con. That's the problem too. To James's point earlier, there needs to be a mechanism where computers are earning money. And the way they do it today with the blockchain is that they're mining and then they get credits for the token or the coin for doing the mining. So they're doing this proof of work mining that gets them the award, if you will, of the coin. So we don't have that. So we're going to have to come up with some credit scheme, like to James's point, that you earn credits by computing in this public mesh computer.
In the Parkinson's test that's currently going, well, it's not a test, I guess, but the point is that it's going on now. How is that? So you've got, is it an international network? I guess it certainly could be. There's no reason why it could be.
So talk
about that a little bit.
Yeah, that's an interesting or fascinating story. A professor at the University of Wisconsin stumbled on computes.com and said, "Hey, I want to do." So she's a linguistics researcher, and she had all of these voice files that University of Wisconsin has permissions to evaluate, and she's come up with some algorithms to run voice files through like a platform to do early onset Parkinson's detection. And she can tell you like probability, like the person that left this voice file has a 30% probability of having Parkinson's disease in the future, that type of research. So she said, listen, I don't have a budget for cloud computing. I can't get my university to buy me additional servers to run my research. She said, but I've got a dozen lab computers that are pretty much idle. She said, could computes help me here? So we worked with her. We deployed the nanocore, computes nanocore to all dozen of those machines. And then she had students that were in her classes that wanted to help with the programming aspects of it. So we taught them how to do it in the computes way, how to build, how to convert her algorithms and whatnot to run in Docker containers on these computes servers. And she is essentially able to process tens of thousands of voice files per day using these disparate lab machines that were at her disposal that she would not have been able to do without computes, without the budget she needed for this exercise. So that was, again, a very important aha moment that demonstrated that not only does it work, but it solves a problem, a business problem. You know, a lot of us techies, we were talking about earlier, we're sometimes fascinated about the technology side of this. So this was the first opportunity, while they're still not paying, you know, we needed them as much as they needed us, you know, to test and prove out this platform. It was that validation that said this really could work as a business. In addition to some very interesting technology.
That's fantastic. But so they're using only their own computers, or are they on an internet? Yep. Okay.
Oh, so that's a really good. There's two interesting really points out of that though. They could, as their company or their school agrees to put this on more machines, they could double, triple, quadruple their footprint, their computing footprint very easily. To your point earlier, Randy, as they find other universities that want to participate maybe in this, they just share that private mesh key, the mesh computing key with them. And then all of a sudden over the internet, now you've got this extended private mesh computer across multiple schools. One more interesting thing, somehow word got out to the National Parkinson's Foundation in the United States of what they were doing. They reached out to us and said, wow, we want to do a case study on University of Wisconsin. And they said, if it's doing what we think it's capable of doing, we know hundreds of research organizations that also have this compute problem. They can't get enough computing power to do the research they need. To James's point, they asked, could we create a volunteer network of friends and family and patients of Parkinson's that want to volunteer their idle compute at home to the researchers to do this computation. So that could be a platform that you don't necessarily need the credits because there's a common goal, I think, between researchers and volunteers. But if we've solved the credit problem, maybe we could get more non-Parkinson's people involved as volunteers too. Maybe not volunteers, but maybe you get paid, you know, $1 an hour for your compute or whatever that MIPS works out to.
Yeah, I think it's more to it than just that. Also, you want to be pretty sure that the applications that are running upon your system are the applications that you think they are, because you can volunteer to be a Parkinson number cruncher person, and all of a sudden find out that you're mining Bitcoin for somebody.
You know,
that would be devastating.
That's an excellent point, James, because at one point in time, my company was reselling a dedicated server to a customer, and I was just by chance on the server and saw there was a bunch of emails going out, and found out that their advertising agency, their communications agency, was using my server that I was paying for and reselling for a campaign for a totally different customer. And the good side of that story, because there is one, is that they were constantly trying to steal everything from us as far as business, going, whoa, you should do hosting with us, blah, blah, blah. And I put together a dossier on that whole thing and went to the people at the IT guy who I know at the customer base and said, look what these guys are doing. What do you think? So that was the end of that. But the point is, anyway, yes, this is a problem. And I was going to also, related, ask you about encryption. We don't need to know exactly, you know, what key kind of you're using, but presumably nothing is sent in the clear, obviously.
Yeah.
Right. Yeah.
So that takes time.
What it means is that you're going to have to come up with some kind of certification for applications, so that you know what the application that's running on your platform is, and it's certified to say that that is what it is.
You know, and some of the engineers on computes have been talking about signing applications, I think, to your digital certificates and a digital signing of apps as they get submitted as tasks. James, maybe that could tie into that story, that these are like authorized tasks, you know, on this private mesh computer that can run.
Yeah, it's one of the reasons why I quite like the Apple ecosystem for applications, because there is that first level of filtering, and unless you get behave yourself, Randy.
Oh,
Let you get past that first level of filtering. I know it's not perfect, but it's better than just have anybody put up any application anywhere that can be totally malicious.
all kidding aside, yes.
Some vetting.
Incidentally, I just recently I was looking at my CPU idly and saw, well, I'm not running anything and I'm at 700%. What's going on? And I found a plugin in Chrome. I don't know what it was doing. For all I know, it was mining Bitcoin or whatever it was doing. I mean, that was to be the most reasonable explanation, actually. And as soon as I removed it, that was the end. It was a Facebook.
Ooh,
It was a Facebook. Well, I was not on Facebook now, but when I used a cleaner that would show. It's called Flatbook, by the way, in case anybody's interested. I don't know what
these Facebook cleaners and things like that are probably one of the most common sources of malware. Because anybody who goes for something like that clearly doesn't really understand what they're doing.
That was one of the SDKs that were used to develop a number of plugins for Chrome that got hacked. It was the underlying SDK. So tens of thousands of plugins for Chrome were compromised. And then the company that was supplying that SDK sorted the thing, but they got attacked. So it was not a direct attack on the plugins, but on the supplier of the plugin developers.
The plugin, in all fairness, now that I mentioned the name of the plugin, and it did seem, I mean, to me, it seemed to be totally legitimate. But what you say, Corrado, totally.
All of them were. It was the underlying technology that got compromised to be mine Bitcoin. Yes.
But it does speak to, well, that's only one thing it could be doing, but that's an interesting point. But it does speak to the problem that James brought up and that we've been talking about, Chris, which is this is some serious business here because of electricity. And in the case of small users, and that was a question I wanted to ask you. So we're talking businesses and schools and universities and, yada, yada. But is there any interest for the single human being who has, you mentioned Raspberry Pis. I mean, if I have a new Mac Mini, which I don't, that I leave on all the time, is that some kind of a candidate for this in the future, or is it not powerful enough? Or what's
I think it would be a candidate in the future. So each machine, when it joins the Compute's mesh network, it kind of creates a profile. It does a quick MIPS calculation. It tells Computes, hey, I'm a Raspberry Pi. I'm running this version of Raspbian Linux. I have 1 gig of RAM, whatever the profile of it is, and it also gives it kind of a location too. So when we have this decentralized queue that we've written that runs on top of IPFS, on top of our distributed ledger, that all of these tasks get submitted to, this decentralized queue can say, I need a machine of this type of caliber to be able to perform this job. So it could ignore all of the Pis asking for work until it finds a task that a Pi is capable of to do, which is, which there's many of operations a Pi could do, plenty enough power to run. So we call it Lattice is the name of our decentralized queuing technology. And it's constantly matching up the right worker with the right computational task. It's also managing the tasks as well. So each task gets sent out with a time to live, a time value associated with it. So if Lattice doesn't hear back, in 15 minutes or 30 minutes, whatever that TTL was set at, it can take that job back away from that machine and give it to someone else. And meanwhile, all of these computations, Lattice is aware of what can be run in parallel and what needs to run in serial. So it can say, if this is part of a parallel task, I'm going to keep distributing work to all the other cores that need this type of work. If it's serial, it says I have, like a lot of machine learning work is serial. They have to learn from the results of the previous task. So it can say, I'll have to wait until a worker picks that work up and does it and continues. What's not in there yet, but I think it'll speak to the malicious part, is that we can start building reputation of machines, kind of like the Amazon does of people that, or eBay maybe that does of people buying and selling. We can start tracking the reputation of a machine to say, are its results typically good? Or do they come back in the time to live within the time parameters, et cetera, et cetera. So that'll be an interesting case. And talk amongst yourselves. I've got some Raspberry Pi little supercomputers I've been building. So yeah, hang on real quick. Yeah.
This is where Chris goes,
Yeah.
Yeah, this is where we remind people that some of our friends are at IT Expo.
They are.
That they can meet Michael Graves, who's one of the stars of this enterprise.
An unsung star.
Now that Chris has come back with the monster, I have a question though, a question observation. The data mining that your application is doing beforehand, classifying the machine, is also an interesting data set that you could work on and look with a big data lens and see what is the status and the state of play of the users. Yep. You have valuable data that is valuable beyond compute.io.
I didn't think about that, but you're absolutely right. I bet the IT shop of an organization has no idea what even should they be upgrading their machines now or wait another year, right? That they don't have that data.
That could be a good trade-off for the IT manager to give you some computing space in exchange for an inventory of what it's running and how it's running.
That's a really good point. Another interesting thing that you made me think about is that, in big organizations, they have SANs and NASs, for storage. And typically, like on a Windows machine, they only use the disk drive just to get it on the network. And then there's all this other wasted file space on those machines too that could, like Computes manages CPU and GPU, maybe it could also use IPFS to manage all of that latent disk space. It'd be the Computes file system, if you will, like all of these disparate machines.
Well, when you're using transient computational power, you're using something that is fleeting by. When you're using space into someone else's machine, physically, could be a bit it's pathological.
Yeah, no, you're right. You're right about that. So this is I did this. I won third place in the Phoenix. It was the Arizona Smart City Hackathon, and I built this little guy to demonstrate the proof of concept. But this is 15 Raspberry Pis, believe it or not. So
it's pretty.
It's pretty, yeah. These are Raspberry Pi Zeros with Wi-Fi, and the Wi-Fi helps me have half the cables, so I don't have all the Ethernet cables running to this thing. But 7 Raspberry Pi Zeros with Wi-Fi on each side, and then a Raspberry Pi 3 on top that I run the IPFS daemon on top of this guy, and then all of these Pis just communicate through the IPFS daemon. Now I got a little blink LED that I can change colors on whether or not it's computing or the level of
all that computing power to change the color of an LED.
But what's interesting though is we got 15 computers here, and the Raspberry Pi 3 is a quad core, whereas the Pi Zeros are single cores. So essentially you've got 18 cores, 15 computers, 18 cores, computes running across all of this. So Computes is physically running 18 nano cores on this little Raspberry Pi cluster, and it acts like a single computer, based on how it's doing the computations.
What are all the colored leads for? If you're using
they were. I got them on sale. They were on eBay. They're just power. They're power cables actually, and I thought they were kind of cool to make it a little more colorful.
Yeah, it makes it look a bit like your mustache, really.
Hey, so this is interesting. So my pitch at the Smart City conference was power meters. There's 1 million smart meters, power meters in Arizona, where our homes have in our utility boxes, they have power meters that have the computing capabilities of a cell phone, basically. And they're on 24 hours a day, 7 days a week, but they only chirp the power consumption every 15 minutes. So my proposal was, let's put computes on all 1 million of those power meters. And then I started doing some calculations. I started trying to figure out what's a typical flop, like what's the flops calculation of a mobile phone. And then I extrapolated that across 1 million and gave it, say some 90% idle factor in there. I came out to a 2 petaflop calculation on just the Arizona smart meters. And when you look on the top 500 world's fastest supercomputer list, 2 petaflops put it at the number 61 fastest supercomputer in the world. That basically, and there's another list that has the greenest supercomputers. Since these are already online 24/7, not consuming any additional power, it would have put it in the number 1 spot.
I don't
number
believe
1
that.
spot.
I don't believe that, because most of the time these meter computer things are going to be sleeping, so they're going to be using.
Okay. Well, if that's the case, we're not number 1 anymore.
So I challenge that straight away.
Oh, yeah, you're right. Probably the clock even stops. The internal clock stops, and it's just revived by a timer for the time the computation requires. So the concern about computational consumption of power and impact you do on the grid with a massive supercomputer of that size is something to look at, because completely on a different subject. If we all moved to electric cars, the grid could not cope with that. So we need to prepare for that.
So here's an idea. What if you got a discount on your utilities, by opting in or allowing your power meter to, do cancer research or something like that?
Well, and the other thing is that you only really use that compute capability at times when there's excess electricity available on the grid.
Oh, true. Yep. And they would know that, right? Yeah, they're the power company.
So there's one thing here. I'm going back to your initial thing about 50 billion IoT different nodes around. They're all communicating in one way or another, and some of them are going to be on Wi-Fi and so on. But I think you'll find that a lot of things like power meters are actually connected to the mobile network grids. So what's the sort of communication overhead here that we're talking about?
That's a great question. So it doesn't work well for chatty applications. I mean, if you're dealing with an application with lots of I/O, computes is not good at that. For example, I in my early stages, I did 9,000 factorial computation. That's like 1 times 2 times 3. I wrote a JavaScript application that did it on my Mac, and it took 7 seconds. I said, okay, now let me send that work to that Raspberry Pi cluster, and it was doing 1 at a time. It took like 10 minutes to do. So then I said, well, wait a minute. Okay, so lots of I/O doesn't work, but what if you could carve out enough work where maybe I could break it up into 3 machines instead of all of those, and give them 1 to 3,000, 3,001 to 6,000, break up the work. It came back in 2.2 seconds. So there's a balance. There is a sweet spot where you have to say, if I'm doing algorithmic or computation without a lot of I/O, it's friendly to the network, and you give the machine enough time to do its computations and get the result back.
Okay. That's interesting. And the other thing, of course, is that the largest, generally for large periods of the day, unused computing resource that most people have, this is probably a smartphone. And they all plug them in to charge them overnight. I used to have visions of James with phones right across the bed, charging all night.
You looked. No, no. If you go into my spare bedroom, that's exactly what you see.
His poor wife.
They're all laid out in lines.
You know, I spoke to him the other morning, and he said the phone's on the pillow next to me, and that's
these visions. When I wake up at 3 o'clock in the morning, I sneak into the spare bedroom, and I'm surrounded by lots of fully charged devices, so ready to go.
Yeah, I've seen James travel. He's got a whole trench coat full of devices.
Well,
it's funny you mention it because I just bought these. A multi-USB charger.
Well, the point really being that they charge them overnight. So, and it doesn't take very long to hit 100% charge. So, if they've already hit 100% charge, and maybe if they're on Wi-Fi, they may become a usable resource overnight. Although what that might do to the reliability if you heat the thing up all night might be a different matter. But
yeah, and we know about reliability. I managed to break my my Nexus 5X just by working it too hard. It got too hot, and something happened, and it
burnt
died.
it out.
I burnt it out, literally. Yeah, I worked it too hard.
Solder melted.
Worked it to death.
Yeah.
Good old capacitors.
Andy, to your point, we've kind of thought about that before. We could maybe add some parameters that say when your mobile device is on power, like charge, like when it's plugged in and when it's on Wi-Fi, when it's not costing you battery power and when it's not costing you 3G or 4G power, you could maybe opt in and start earning money, maybe to do like what James was talking about earlier, Parkinson's research
not
or something.
Earn money, just earn creds that you
earn something.
Yeah.
Also, there are many. I have 2 devices that I use very rarely, but I have Nexus 5 sitting here. It's not the most powerful thing in the world, but it's used for the doorbell, and I turn it on once in a while. It's not even connected. Yeah,
that's Randy, that's a great point. I was talking with someone at Intel about this idea, and I was thinking, does Intel have a venture fund? Would they be interested? And he was like, "This is everything that Intel is against." He said, what you're doing is you're allowing people to bring all these keep these legacy devices useful rather than continuing to upgrade. To your point, you could bring all of James's legacy mobile devices together, and put them all on, build a mobile supercomputer array, if you will, of disparate devices, and there you've got reclaimed computing power.
Yeah, and perhaps they would only come online when the sun shines here and my house batteries are fully charged. So I've got spare electricity and I've got spare compute. When all the spare things go to true, then it becomes available.
Yep, that's brilliant.
Well, at any rate, I think we need to remind people to go to Computes with an S on the end. I screwed up the link earlier this week. Sorry about that. computes.io. Chris, presumably there's a way to contact you on that site somewhere, or to contact someone.
Yep. There's a form, a contact form on that site. And by the way, we got the big checkbook out in bought.computes.com. So both links will work, but you can hit me at chris@computes.com now too.
And you should have bought compute.io singular, because I'm not the only one probably who made that mistake. But for those listening, make sure that you do put an S on the end. Chris, you are the greatest guest. Of course, I say
you're too kind. Thank you.
But it's just great having known you for many years, and you're welcome anytime. This is an interesting endeavor, but we'll see what you're doing next year.
Very, very stimulating.
Thank you, Randy. Thanks, gang. It's been a lot of fun talking with you guys. You guys have always got so many ideas and input and feedback, and I can't thank you enough. Thank you.
Okay. Thank you, Chris. Thanks everybody who participates. We love y'all. I didn't make too many mistakes, and I'm directing and producing this thing all by myself. Yeah. So here we go. I'm going to sign off. And
good job, Randy.
All she wrote.
Yeah. Nice.